Hi guys, in this episode we're going to talk about subgames and formalize or formally define the Subgame Perfect Nash Euilibrium. Alright, so here I have two very important definitions. So the first one is the following. A node, so we just name a decision node, X, in the game tree is set to initiate a subgame if neither X nor any of its successors are in an information set that contains decision nodes that are not successors of X. All right? The second important definition is that a subgame is the tree structure, part of the tree, that is defined by such a node X and all its successors. All right? So let's look at some examples. So let's suppose this is the extensive form I have. It starts with a decision node X and I named all the decision nodes. And so here, whenever you see brackets, it basically means the final terminal nodes. So the game is over and so players receive their payoffs. So here, let's consider which parts of, so the subgames are basically parts of a game, all right? And so what parts of this game is called subgame? Well, here, probably the easiest sort of way to start is sort of the lost parts of this game or the lost branches. So this is a subgame of this game. So the decision node D, and afterwards there's no successor decision node, so it's just D itself, and so this is called a subgame. So it basically satisfies both of these assumptions simply because there's no successor decision node after D. Similarly, this is also a subgame, all right? Meaning here, just one player makes a decision to choose either this or this. Here, another player, or maybe the same player, choosing between two actions. All right, I'm going to use a different color, blue. So one question, so is this a subgame? So this part of the game, all right? I'm basically cutting the branches. Well, this is not a subgame. Well, why? Well, because the subgame is a tree structure defined by a decision node and all its successors, all right? So all its successors. So it starts, so all subgames must start with a single decision node, all right? It starts with A, and then all the successor decision nodes, so the part of the branch, part of the tree that includes all these successors decision nodes must form or can form a subgame. And so here, C is a successor of A, but you do not include it. And therefore, this blue area, meaning this A and then this single branch, D, and then these two branches, this is not a subgame. Well, what is a subgame here? I'm going to use the red color. Well, this entire starting with A and including C, D, this is a subgame. Very well. So I'm going to simplify things a little because the picture is going to get ugly later. So let's ignore this part of the game, okay, for now. Well, clearly, this is a subgame, right? Starting with B. This is a subgame starting with T. So once again, a subgame must start with a single decision node, or just one decision node. So it cannot start with two decision nodes. So here, for example, so I'm going to also erase this part because it really is not much relevant. But if you like, you can imagine there is something going on here. There is something, some part of game, there's branches here. So here, when I come to these decision nodes, for example, can I say this is a subgame? No, I can't. Why? Well, because here, again, it contradicts with this definition. The subgame must start with a single decision node. Here I have two decision nodes. So this cannot be a subgame. Okay, what else? What about this? Can this be a subgame? it starts with a single decision node and all the branches or all the successors, right? There's no successors after V, and so this sounds like it is a subgame. It can't. Why? Well, because it contradicts with the first definition. It says, remember, neither X nor any of its successors are in an information set that contains nodes that are not successors of X. So here, V is an information set with W, which is not, all right, which is not a successor of V, and therefore you cannot, this cannot form a subgame. Put differently, a subgame cannot cut any information set or sort of break, right? So be careful. A subgame shouldn't break, cut any information set or any branch. So therefore this is not a subgame. Well, okay. So V is not starting a subgame, W is not starting a subgame, but can they be part of some subgames? Well, yes. For example, can I say this is a subgame? So Z, it starts with Z, all right? Very good, it's singleton, all right? And then it has V and then, a bunch of other things. Well, this is not a subgame again. Why? Well, because you're cutting this info set. All right, or put differently, remember, neither X nor any of its successors. So here, Z is not an information set that contains other decision nodes that are not successors of Z. But here, V, which is a successor of Z, is an info set. All right, and it is an info set which has some decision nodes, which basically is left outside of the subgame. All right. So basically, what we are trying, or what this definition is trying to say, is that if a subgame includes some nodes, some decision nodes from some information sets, well, you know what? This subgame must contain all the decision nodes in these information set. So therefore here you cannot sort of include V but exclude W. You have to include W as well. But then the question is the following. Can I say this is a subgame? All right? No, this is also not a subgame. Why not? Well, here the problem is, once again, Z is singleton, so that's perfect. But here V, which is a successor of Z, is an information set that includes decision nodes that are not successor of Z, right? W is not a successor of Z. So if you don't remember what it means a decision node is being a successor of Z, that means from W, if you want to walk all the way up to Z, you can't do that, because from W you can walk up to Y and then to X. And don't forget, you cannot walk down. All right, so W is a successor of Y and the successor of X, but it's not a successor of Z. So therefore, this is also not a subgame. Well, okay, then can I say, this entire game is a subgame? Yes, I can say that. The entire game itself is a subgame. And in fact, here I have a definition. So subgames that start from nodes other than initial node are called proper subgames. So this is a subgame, but it's not a proper subgame. So if you remember, I had branches here, right? So here I had branches, and so these were all proper subgames, but this entire game is not a proper subgame. All right? Now let's look at this example. So player 1 has 3 strategies, actions here, A, B, C, and then player 2 moves. He has 2 actions, player 3 has 2 actions, and then player 3 moves or player 2 moves. But be careful here, player 3 cannot distinguish player 2's actions, and here player 2 cannot distinguish player 3's actions. And then here, player 3 has 2 actions and then the game is over, and here player 2 has 2 actions and then the game is over. So the question is, how many subgames are there in this game? 3. Well, don't forget again to remember the subgame must start with a single decision node, and the sort of the boundaries of this subgame, or this boundary is just sort of a hypothetical thing, but the subgame shouldn't break any branch or any information set. So therefore, a decision node starting here, this is not a subgame, all right? Because you're breaking the information set of the third player. So then, what is the first info set? A subgame. So here, the subgame starts from the second player's decision node. So this entire thing is just one subgame. Right? You cannot divide it into smaller pieces. And then this is another subgame starting with the third players. So I have 2 decision nodes, 2 subgames here, and then the entire game itself is a subgame. So here in this game there are 3 subgames, one with starting with the second player's decision node, one with starting with the third player's decision node, and the game itself. But only 2 of them are proper. So this one and this one, these are the proper subgames. The initial game itself is not a proper subgame by definition. Now let's consider this game. So player 1 has 2 actions, UD, let's suppose. Player 2 has 2 actions, AB, and then player 3 has 2 actions, left, right. Okay, so the question is, how many proper subgames? Proper. Well, the game itself is a subgame, right? What I'm asking is a subgame other than the game itself. So how many proper subgame does this game have? Proper subgames. How many? Well, if you look carefully, starting from any decision node, all right, so this is the initial node, all right? So other than initial node, start from any other decision node. If you try to include all the successor decision nodes and try to form a subgame, you will have to break the information set, right? So for example, this is not a subgame because you're breaking the info set, meaning so this is this decision node, this is X in a sense, in an information set that is not a successor of X. So this is not an info set. Well, exactly the same reasoning, this is not a subgame. Well, can I include both? No, remember the subgame must start with a single decision node. Well, what about this guy? So can I, for example, include this? Can this be a subgame? No, because once again, it includes a successor, right? It has to include a successor, but this successor is an info set that is including a decision node that is not a successor of this one. So meaning you're breaking the info set again. So therefore, there's only one one subgame in this game, which is the entire game itself, or the subgame that starts with the initial decision node. And therefore, how many proper subgames are there? 0. There's none. Now let's look at this game. So this game starts with player 1, and then player 1 moves again, and then player 2. So how many proper subgames are there in this game? Well, if you look carefully, once again, the subgame starting with this decision node is not this decision node does not start a subgame because it is in an information set which is not a successor of this one. Same here. So this decision node, however, does start a subgame. So therefore, you know what? This is one subgame. What else? Well, there remains only the initial decision nodes, and so there's only 2 subgames in this game, and there's only one proper subgame. Okay, so I'm hoping that this concept of subgame is clear. Now, if it is, let's talk about Subgame Perfect Nash Equilibrium strategy. So a strategy profile is a Subgame Perfect Nash Equilibrium if it specifies a Nash equilibrium in every subgame of the original game. Okay, so I know this definition has a lot, so I will explain it with some examples, but understanding it is very important. So here, let's try to see what this definition may mean. Well, first off, remember the strategies for player one. Player one's strategies, I'm not talking about Subgame Perfect Nash Euilibrium strategy, just the strategies. So here, player one has 1, 2 decision nodes. So for each decision node, an action. So that means the strategies for player one are going to be tuples. All right, so something like ML, MR, so this is M, NL, and NR. All right, so he has 4 strategies. What about player 2? Well, player 2 has 2 strategies because he has only one info set, U and D. All right, so now let's consider some strategy profiles, right? We can write a lot of strategy profiles. For example, ML, comma, U. Is this a Subgame Perfect Nash Euilibrium strategy profile? Well, what does that mean? That means it must specify Nash equilibrium at every subgame. How can I check that? Well, first, put the arrows that this strategy profile specifies. It says player 1 is going to play M, and then he's going to play L, right? And then player 2 is going to play U. Question is, does this strategy profile specifies Nash equilibrium at every subgame? Well, remember this game has 2 subgames. The game itself and then this proper subgame. So those strategies must specify Nash equilibrium at each game, each subgame. Meaning this must be a Nash equilibrium, all right? So this must be Nash equilibrium. So every subgame perfect Nash equilibrium strategy profile, first of all, must be a Nash equilibrium strategy profile. And second, in every subgame, there are only one proper subgame. The strategies, well, here in this subgame, what are the strategies? Here in the subgame, player 1 plays left and player 2 plays U. So this is the strategy profile induced from this mother strategy profile. All right. So once again, this is the mother strategy profile in this game. But when we concentrate only on this proper subgame, this strategy profile will be reduced down to this one because M is irrelevant, right? Because this action M is outside of this subgame. So it's LU, this is the strategy profile. Question is this a Nash equilibrium in this subgame? So forget about the rest of the game. LU, will it form a Nash equilibrium? Well, let's check. Given that player 1 plays L, is it best response for player 2 to play U? Well, it is, right? Because 2 is higher than 0, so U is the best response to L. Now, question is, given that player 2 is playing U, is it best response for player 1 to play left? Well, if he plays left, he's getting 1. If he were playing right, he would actually get 3. So you know what? Player 1's best response is not left. So therefore, LU is not forming Nash equilibrium in the proper subgame. Hence, I don't need to check if MLU is a Nash equilibrium of this entire game or not. Well, why? Well, because remember the definition says a strategy profile is an SPNE if it specifies Nash equilibrium in every subgame. Well, in this subgame, it fails to specify a Nash equilibrium. So therefore, even if it does specify a Nash equilibrium in the big game, who cares? This is not a subgame perfect Nash equilibrium. So it's a Nash equilibrium, but it's not a subgame perfect Nash equilibrium. All right? So we get rid of one strategy. So let's check another strategy, okay? I am just making up some examples, right? There are many examples you can think of. So let's consider this one, MRU. All right, so this is another strategy profile. Is this SPNE? How can I make sure? Well, first, is this Nash equilibrium? This is what I have to check. Second, well, when I look at this strategy and focus only on the subgame, what is going to be the reduced strategy profile? Well, here player 1 plays M, so let me put my red arrows again. And player 2 plays right, not left. Okay, so I need to put my red arrow here. And then player 2 plays U. I don't need to change that one. Very good. So here, the strategy, reduced strategy is RU in this subgame. Is this a Nash equilibrium of the proper subgame of this game? Well, question mark. Let's check. So given that player 1 plays right, what is the best response for player 2? Is it U or is it D? Well, clearly it's not U, it's D. So you know what? U is not a best response to R. So what does that mean? That means player 2 is not best responding, and hence RU is not a Nash equilibrium of this subgame, and hence MRU strategy profile cannot be Subgame Perfect Nash Euilibrium strategy profile. You see the trend. I'm verifying, I'm checking, I'm guessing, and then verifying if it is in a Subgame Perfect Nash or not. But here I also actually, what I do, some sort of a backward induction, right? I am finding the Nash equilibrium in this game in a sense. So I did not create this MRU strategy out of thin air. I knew that L wasn't a best response to U, R was a best response to U, so I put R instead. But now I realize that U is not a best response to R, so you know what? I should maybe do RD. So maybe RD is going to be best response. But again, what you can do, you can basically just make a guess and then verify it, or use sort of a generalized backward induction. How so? Use the backward induction and find the Nash equilibrium at every subgame and start from the last subgame. So in this game, this is the last subgame. Find the Nash equilibrium of this game and then erase it. Let's find the Nash equilibrium of this game. What is the Nash equilibrium of this game? Let's find it. If player 1 plays left, the best response for player 2 is U, so I underline this too. If player 1 plays right, the best response is D, so for that reason I underline this. If player 1 plays U, the best response is going to be R, so I'm going to underline this. And if player 2 plays D, the best response is left, so I'm going to underline this. So what do I see? There is no sort of payoff couple that are both underlined. That means there is no pure strategy Nash equilibrium. All right, but what does that mean? That means, remember, every finite game has a Nash equilibrium. Maybe not in pure strategies, but then has to have a mixed strategy Nash equilibrium. So therefore, I have to find the mixed strategy Nash equilibrium of this. How can I do that? Well, I mean, simple. Just write, I am not going to solve it, but just write the normal form representation, P's and Q's, and so find the mixed strategy Nash. Once I find it, I calculate the expected payoff of player 1 and 2 under this Nash equilibrium, all right? And then see what player 1 is going to pick. Is he going to pick M or is he going to pick N? And then once you figure this out, you will actually see what the Subgame Perfect Nash Euilibrium outcome will be, and then the rest is going to be just bringing up the strategies together. That's it.